Hey guys, magandang araw sa lahat. Ah, ngayong araw, i-emphasize ko sa inyo kung paano mag-interpret ng Anova table. Basically, ito yung output SPSS natin based doon sa data on agricultural research. Nangyari, meron tayong dalawang factor, yung density, land, at saka ah, fertilizers effect. Dalawa yung factors na. And then yung yield natin ay uh, yield crop. Ito. So since dalawa yung factor natin, we use yung two-way analysis of variance. So ito yung result niya. Basically, meron tayong uh, dalawang levels doon sa density land. Then meron din tayong tatlong level doon sa fertilizer spec. Ang ibig sabihin ng warning, ang SPSS kasi hindi na i-compute yung post-hoc test kasi dalawa lang yung level. So, basically, walang nangyayaring multiple comparisons kasi isa lang yung combination niya eh. Kaya hindi na i-compute. But anyway, hindi naman big deal yung warning na yun. Then, dito sa descriptive statistics, as you can see, uh, sa density saka high density, mas mataas yung high density kaysa sa low density. Kasi yung mean niya ay 177.24 as compared doon sa low density land si 176. So mas mataas si high density land kaysa sa low density land. Tapos ito yung mga interactions effect mean between yung land density effect at saka and fertilizers effect. So, yun yung interaction niya, 176. Then, dito naman sa baba, yung mean ng fertilizers effect. So, as you can see, mas mataas si fertilizer C kaysa fertilizer BNP. So, sa standard deviation, halos magkaparehas yung scores nila. So, definitely, we have a suspicious expectations of uh, homoscedasticity. For the Leben's test, ito yung test for the equality of error variance. So, ibig sabihin dito, ang null hypothesis natin is that we want to assume that the error variance is the same across the levels of the groups. Ano yung groups? Ito yung treatment effect natin, yung density effect at saka yung fertilizers effect. So, we want to see yung residual effects ay constant across the levels of those groups. So, as you can see, mataas yung p-value niya. So, definitely, we have to accept the null hypothesis. And this implies that the error variance is constant across the levels or across the groups. So, in other words, we did not violate the assumptions of homoscedasticity. Test for heteroscedasticity using Bruce Pagan test for heteroscedasticity. Ito namang test, parehas lang pati yung C11 test. Kaya lang si Bruce Pagan test, ginamit niya yung chi-squared statistics, which is yung ano, ang ang null hypothesis niya dito is that yung variance of the errors, dinidetect niya yung relationship kung mayroon bang association between the variance or between the error variance and the independent variables. Ano yung mga independent variables natin? Yun, sinasabi ko nga sa inyo yung groups ng treatment effects, yung fertilizer at saka yung density plan. So, ito ginamit niya yung chi-squared statistics. Parang kinuha niya yung observed value and the predicted value, and then siguro pinel-plot niya. Si Bruce Pregantes, meron siyang ano, ah, ito, choice. Ginamit niya dito is kung gagamit ka ng predicted values, yun yung expected value mo kasi kukunin. Pero kung gagamit ka naman ng univariate models, gagamitin yung ano, parehas lang. Ang ginano lang niya is yung ginamit niya is yung univariate model. Since ito naman nagbe-base tayo sa predicted values. So, it's not a big deal kung ano yung gamitin mo, model or predicted values. So, dito sa test na to, si Bruce Pagans, tinitest niya kung mayroon associations. So, as you can see, yung p-value natin ay mataas. Ibig sabihin, the error variance has no associations between our independent variables. So, if there's an associations, then you expect na yung p-value is maliit at 0.0 level of, or less than 0.05, less than the level of our significance. Next table, yung Anova table, which is test of between subjects effects. Ito kasi yung corrected model. Ito na yung combinations effect ng our factors, main effects at saka interactions effects. Yung si density, tsaka si fertilizer, tsaka interactions effect nila dalawa. Tapos dito naman, ito yung our error or residuals or error terms. And then yung total, pag itinotal mo yan, from 30.0811, tapos total mo 5.1 hanggang dito, ito yung lalabas. Tapos ito yung regression total natin. Kumbaga sa ano, sum of squared regressions. And then ito yung sum of squared total. And ito naman, ito yung sum of squared yung sa fitted model natin. Ito ginamit natin yung ganoon din, parehas lang sila. Kaya lang kasi ito, pag itinotal mo kasi ito, 11.6641 plus 5.126.08 4.0.42 at saka 30, ang total yan is 41. So all of these are the sum of squared and then the degrees of freedom, and then this is our mean squared. In other words, 11 sum squared divided by the degrees of freedom. Ito yung mean squared. And then, ito yung paano kinuha ito. Ibig sabihin, type 3 sum of squared, i-divide lang sa degrees of freedom. Ang makuha mo, mean squared. Yan, ito na yun. Pag sinabi mo kasi mean squared, ang mean squared error natin is 0.337. Then ito yung computation ng F-test. Ito, 2 divided by 30 divided 0.213 divided by 0.33 equivalent to 6 0.631. 3.034 divided by 0.33 equals 8.99. 5.120 divided by 0.337 is equal to 15.17. So this is our F computed, and this is our P value for the F computed. I'm not explaining the details. So, you know, pag mahina ka kasi sa statistical knowledge or statistics knowledge, medyo mahirapan ka. Pero kung broaden yung utak mo sa statistics, talagang maintindihan. Ito kasi si partial ETA squared, ito yung estimated effect size. These are the percentage of variations. In Y, percentage of the variations in response variables natin na kung saan uh, gaano in-explain niya o in-account niya. So, here, 0.27 point 0.27 or 0.28. So this is actually 27.7% of the variation in response value that has been accounted by combinations effect, yung density, fertilizers, and the main effects and the interactions effect. That has been accounted by the by the combinations of the main effects and the interactions effects of density and the fertilizers. That is 27. And then, pag itinotal mo kasi ito, 0.14, 4, 0.167, 0.01, total net is 0.277. Kaya, ito yung percentage ng combination nila ng effects. 0.14.4% of the variations in response uh, value that has been accounted by the density effect. And then 16.7% of the variation in response variables or in yield graph that has been counted by the fertilizers effect. And then only 1.4% of the variations in yield curve that has been accounted by the interactions effect of density and fertilizers. So maliit lang siya kaya hindi siya significant. Ito, hindi siya significant. Ang p-value niya is nasa 53% which is greater than 0.05. Unlike yung density at saka fertilizers effect, medyo uh, masyadong mababa yung p-value niya. 0.0025 sa fertilizers effect, and then 0.0018. So basically, very significant siya. So this would mean that density has a significant difference. Density effect has a significant difference on its level. Same true with the fertilizers effect. It has a very significant it has a significant difference on its level. So that is would be all for the interpretations of the analysis of variance in two-way factors. If you have some comments in this video, don't forget to likes and shares. Paki-click na rin yung notification at paki-subscribe na rin. Thank you.